All right, so this is AP Calculus. We're going over the Unit 6 pretest. There are all the points that you can get. Let's go over number 1. So the slopes for number 1, I guess we can just look at the scoring guide to do them. Well, we should do at least a few of them, right? Notice that whenever x is 0, you're always going to have a slope of 0. So where's x 0? All of these 4 points x should be 0. So slope of 0, slope of 0, slope of 0, slope of 0. And if you're really, really bad at drawing slopes, I guess you can also say, yeah, that was a slope of 0. It definitely helps me to be like, is that really a 2 or is that really 1? But I don't even know if you can do that on the AP test. That's a good question for John. If I have a slope of -1, it doesn't matter. Slope of -1, or sorry, a x coordinate of -1 is the same thing as an x coordinate of 1 because it's going to be to the power of 4. It's always going to be even, which means this point and this point should have the same slope. This point and this point should have the same slope. Let's plug in y is equal to 3. When y is 3, 3 minus 2 is 1. 1 times 1 is 1 because this is 1. All right, so it has a slope of 1, has a slope of 1. You can label those 1 and 1 if you'd like. If I come down here to a y of 2, when y is 2, 2 minus 2 is 0. These are both 0 and 0.
Wait, what are you plugging in?
I'm plugging in the x and y coordinates. So for example, for this point right here, I'm plugging in 1 for the x and 2 for the y because the coordinate pair is 1, 2. So the 1 is the x. This x right here is 1. The y is a 2, so this y is 2. 2 minus 2 is 0, and then 0 times anything. That's why I have a slope of 0 here. Yeah, good questions, and if you have more questions, just please ask. When I have a y coordinate of 1, 1 minus 2 is -1, and this one is always going to be 1, so I have a slope of -1, -1, slope of -1, -1. And finally, y coordinate of 0, 0 minus 2 is -2, so this is a slope of -2, -2, slope of -2. I can do it better, -2. Questions? Then we're on to part B. Is there yeah, there's not an extra question. Sometimes I really highly recommend just rereading the question after you answer it because sometimes you're like, oh, and then also draw the line from whatever, just like we had in that self check, right?
Wait, so then what do you put on here?
In terms of points, yes, scoring guide. So for each of the 0 slopes, you get 1 point. And
so like A.
The front part is just how many out of that you've gotten.
So if you're scoring these cross all of the zeros, that's +1. Everything else +1. So there's 2 points there out of 2. For part B, we are looking for describe all the points where the slopes are negative. I'm going to underline that. That's the important part. Slope. Another word for slope is dy dx. That means slope. It means the tangent line. It means a lot of things. In this case, it means the slope. So we want this dy dx to be less than 0. That's what it means to be negative. Well, hey, we know what dy dx is. Dy dx is x to the power of 4 times the quantity of x, or y minus 2. So we can now say x to the power of 4 times the quantity of y minus 2. That thing has to be less than 0. And of course, there's the graphical way of doing this, which is really fast. Let me do it the algebraic way first, though. And now I'm saying, okay, how can I make this less than 0? How can I make this negative? Well, x to the power of 4 is always going to be positive. It's impossible to make that negative. So I just kind of ignore it. Now I just say, okay, well, that means the only thing that can be negative is y minus 2. Well, now I have the inequality. Y minus 2 is less than 0. How do I do that? Add 2 to both sides, plus 2, and I get y has to be less than 2. This is half of the answer. If you just wrote this, you would not get your 1 point. Because check it out. If y is less than 2, so y equals 2 is right here. So everything under this point should have a slope that's negative. But what about these points right here? Those aren't negative. Those are 0. So we have to have an extra thing that says, oh, also x can't be 0. So we can say y has to be less than 0, and x cannot be 0. Just writing these 2 things will get you the 1 point. You can see that in the scoring guide. The 1 point for the description where you say x is not equal to 0, y is less than 2. And of course, this is the graphical way of seeing that too. You see up here when you're doing your slope field, you're saying, oh, all these slopes are negative when I'm below this certain point. And you can do it that way too. Yeah, so that's +1, just for getting whatever's in that box. So that's out of 1 point. And then we're on to part C, which is the majority of the points. So let's do this. So I have the initial condition, x is 0, y is 0, and I'm trying to find the particular solution. I'm always going to underline that. You should underline it too. Just get in the habit of saying, okay, when I'm on unit 10 and well, you won't see this on Unit 10, but if, like past Unit 10, we're doing review, when I see a particular solution, that's the indicator that says, okay, I'm doing the separate, integrate, evaluate, and if you want that 1 or 2 maybe points for isolate. And some of them are actually kind of easy. It's kind of worth doing, I've noticed. Okay, so I'm going to recopy this down, dy dx.
Further question.
Yes.
So is there any time when you do the separate, integrate, whatever, separate, isolate, integrate, no, you know what I meant, when it's not a particular solution?
Yes, and that's from like 1998. That's the only time I've ever seen where it doesn't say that. Yeah, it's a very key word. If you see a slope field for part A and you get down to part C, I guarantee they're going to be asking you to do these steps. That's another kind of way to do it. Part B is always random though. Yeah, so we're going to solve this. I need a fraction equal to a fraction. So to make the right side a fraction, I'm going to just divide by 1. And then I cross multiply. Cross multiplying, I get 1 dy on the left-hand side is equal to, and then I cross multiply the other direction in green. There's going to be x to the power of 4 times the quantity of y minus 2. That's all times dx. I just kind of jumbled these all together. They're all being multiplied. I'm not done. I don't get my point yet. I have not separated because I have a mixture of y's and x's. So whenever I have y minus 2 in parentheses, this entire set of parentheses, I'm going to divide by that on both sides. I'm literally going to say divide the right-hand side by y minus 2, this quantity of y minus 2. I'm going to divide the left-hand side by the quantity of y minus 2. After doing that, I get 1 over y minus 2 dy. And on the right-hand side, those cancel out, so I'm left with x to the power of 4 dx. I have now separated. I have now completed step 1. And if you see over here, 1 point for just separating the variables. So I come back over here. I now can give myself 1 point if I separated those correctly. And also note, you get 0 points if you can't do that correctly. 0 out of 6 if no separation of variables. From here, we are now going to do what? You will shout out.
Integrate.
Yeah.
Integrate. There it is. So I'm going to integrate. I don't like fractions. Get rid of fractions by using negative exponents. Y minus 2. All that to the power of negative 1. Yeah. And then I still have that dy is equal to the integral of x to the power of 4 dx. Now I actually have to do the integration. Yes, Gio.
When you do the integration, you drop out the dy and dx, right?
Yes. So whenever you do the integration, this integral symbol disappears and the dy disappears. And don't forget your cake, your plus c.
But only after you have the answer.
Only after, yeah. All right, so normally when I take the integral, I look at the outside, the most outer house, and I say, okay, this number is going to go up a power plus 1, and then I divide down by that. So negative 1 plus 1 is 0, divide by 0. Oh, I must need a special rule because I can't divide by 0. My special rule says natural log. So this is going to be the natural log of absolute value. If you do not do absolute value, you do not get your point. Unless there's some weird domain constriction where you don't have to do it. By default, always assume absolute value whenever you're doing natural log house for the antiderivative. Absolute value of y minus 2 and absolute value, done. Why do we not have to use taxman? We always have to check for taxman, and I forgot to do it, but I didn't have. Yeah, check dinner. Always check your dinner. What is your dinner? Someone shout it out. What is your dinner for this one? 1. That's why we didn't use taxman. If it's anything other than 1, use taxman. I think one of these pretest questions had you answer that. So this is on the right-hand side. Okay, I'm going to go up a power. This is now x to the power of
5.
Divide down. Don't forget your
Cake.
cake plus c.
No, we should have cake one day.
We should really have cake.
Yeah.
Cheesecake. Okay, so you get 2 points for the antiderivatives. So I come back over here. You get 1 point apiece. 1 point for that one, 1 point for that one.
Wait. Oh, I forgot to do
Coming back over here, if you use your constant of integration, if you have your plus c, you get a point. Plus 1. Okay, we just did step 1, separate. Step 2, integrate. We are now on step 3, which is to plug in, evaluate.
that. Wait, why
Yes.
are you adding plus 1 in C?
I'm saying that's a point.
Oh.
You get a point for each of those. Whenever I do a circle plus 1, that always means you get a point for whatever you just did. So right now we are a total of 4 points. How many points do you need on the free response question to pass the AP test?
3.
3.
3.
3.
You just need 3. Look,
Never.
ignore part A, ignore part B. If you did your separate and integrate correctly, which, I mean, it was a little bit hard, but it's like just such little work. 4 points. You are well on your way to passing. All right, so from here, I'm now going to do step number 3, evaluate, which means plug in your x is equal to 0, y is equal to 0. So this is going to be natural log. Absolute value of 0 minus 2 is equal to 0 to the power of 5 divided by 5 plus c. Normally on the AP test, you stop here. Just by doing that, you stop there, you get your point. Because if you, on the AP test, if you do some mathematical error incorrectly, they will take that point back away. That's why I tell the people to stop
For
here.
real? So if
For
you
reals.
stop here and then
If you stop here, you
if
get your point.
keep going and you get it wrong, you don't get that point. But if
Yes.
you stop here, you do get that point.
Yes.
That makes no
weird.
sense.
So if you get the constant of integration correctly, then they'll give you the point.
That's scary.
It is, and that's I'm
Wait,
telling you the
that's
strategy.
only- wait, how many points do we have already?
We are now up to 4. We have 1, 2, 3, 4.
Oh, so okay. You don't have to like do the absolute value anymore.
You don't after you apply it. Like so, absolute value of -2 is 2. So I can now say this is natural log of
Yeah,
2. Now I can drop the absolute value because I've taken the absolute value. You always have to take the absolute value, and then when you write it, you can drop the absolute value because I've
So
taken it.
if it's a negative, you have to drop -2. Like
Yeah.
after the absolute like.
You drop
Yes,
absolute value means the distance away from here, so it's always going to be longer.
precisely. Yeah. And
So
in
I'm
my
gonna-
class, this is the only place where you'll get your +1 because I need you to simplify. I'm making it slightly harder than the AP test. I'm making sure you know how to simplify.
See, if I would have kept going, they would take my point away because I would have dropped the negative.
Good job for stopping it.
I didn't stop that.
All right. I'm not going to do part 4 isolate because you only get 2 more points, I believe. No, you get 1 more point. I'm not going to do all the extra work for 1 more point. Sorry,
So
Claire.
one more time.
Okay. Thank you.
Yeah, moving on to number 2. And did I give my, yeah. On the answer key online, I'll make sure that it has that extra step if you guys want to look at it later, but it's obviously not going to help you today. This one was a little bit challenging because it has weird letters, and that's the thing that confused most people. What I can really say is this is y prime is equal to 1/5, 100 minus what letter? Is it x or y?
Why?
It's y. That's the confusing
Oh.
part.
It's
So we're
whatever.
doing like the y minus box thing. Is it like the y minus?
No, it's not in point slope form, no. Yeah, that was this part right here. The fact that that's a y is the confusing part because it's always dy dt, and this is the y, which means when I take the derivative of b, I can't take the derivative of y. The derivative of y is not 1. The derivative of y is y prime.
I always mess that up.
That is the hard part from this question, in my opinion, at least, for part B. Let's take a look at part A. Part A is pretty straightforward. It's saying, hey, is it gaining weight faster when it weighs 40 or 70? Literally, you need to show your work to get the point. You need to plug in 40 and plug in 70 for B. B is the weight, right?
Yes.
You just plug it in. So here we go. dB dt. And then you can, if you're fancy, you say, I'm evaluating it when I'm plugging in 40. And then if you come over here, that's 1/5, 100 minus 40. And then actually simplify this thing. 100 minus 40 is 60. 60 divided by 5 is 12. And if you can't do that mental math as fast, just take your time and get it because knowing that it's 12 is important. Let's do the derivative dB with respect to dt, with respect to t. Evaluation bar at 70 this time. So I'm plugging in 70. 1/5, that's or quantity of 100 minus 70. 100 minus 70 is 30. 30 divided by 5 is 6. Now that we know what the rate is when the bird weighs 40 and the rate is when the bird weighs 70, we know that the rate is obviously higher, which is asking for here, because 12 is bigger than 6. That's the argument that you're making. You're saying, hey, 12 is bigger than 6? Done. So we'll come over here, and this is how you write it. Bird is gaining weight faster at 40 pounds, 40 grams,
Big bird.
and you say because dB dt evaluating for 40 is bigger than dB dt evaluating for 70. Or you can say this in words, so you don't have to be so formal about it. You can say the rate is higher when the bird is 40 pounds. Or 40 grams. 40 pounds is a big bird. Maybe literally. I wonder how much big bird actually weighs. Okay, anyway, there it is. That's kind of how you say it formally, but yeah. And how many points do we get for this?
1, 2.
So if you actually use dBdt, if you're somehow showing that, oh yeah, I'm plugging in the dBdt, just showing it, just using it, Even if you get these numbers incorrect, you can still get the point. It just says use, not get it correct. You get a point. So obviously,
you don't get it correct at all.
say again?
You don't have to get it correct to get the point.
Nope. You just have to somehow show that you're using it. If you show that you use it, you get a point. So we not only showed it, but we got it correct. And then on top of that, this is the hard part. You need to get the answer and have the correct reason. So the answer is, oh, they even answered like I did. That one is bigger than that one. So therefore, it's gaining weight, or faster, yeah, 40 grams. So you have to have 40 grams. I'll kind of box the part that's important, and you have to have the reasoning. Those two parts will give you the other point, and that's out of 2 points for part A. Other questions? Okay, part B. This is the tricky bit that no one got. So it's asking what is B double prime? What is that equal to? But we know what B prime is, so let's come back here. B prime is this thing. I'm just going to rewrite it. B prime is, oh, too fast, 1/5, in parentheses, 100 minus B. And if you don't like capital B, you can switch it out for Y mentally, but you can't do it on paper because then they'll be like, oh, you're getting it wrong, wrong variable. There it is. Think of this.
You write B equals Y, and then you use Y.
Then that's fine, actually. Yeah, because you formally define that it's equivalent. Yeah. But in your mind's eye, think of this as Y prime is equal to 1/5, 100 minus Y. Okay, so let's go ahead and simplify this. 1/5 of 100 is? 1/5 of negative B is negative 1/5 B.
Yeah, sure.
So this is B prime. We all nod our heads, that's B prime. Now let's take B double prime. If I take the derivative again, the derivative of 20 is 0, so don't worry about it. The derivative of B is
1/5.
B prime. Because we can't think of this as Y. If I take the derivative of Y, it's Y prime. I can't turn it into 1. Yeah, so think of this as B prime, so the answer is negative 1/5 B prime. And, oh, we know what B prime is. B prime is that thing right there. So this B prime and this B prime are the same thing. I'm going to do a substitution problem. This is now equal to, I'm going to copy down this negative 1/5 times the quantity of B prime. And what is B prime? B prime is this whole thing, so I write another 1/5 times 100 minus B.
This is not worth so many.
I know. I'm not going to spend too much time on this. This is equal to negative 1/25 of 100 minus B. Okay, that was 1 point.
No, I don't want to.
And that's why I chuckle.
This is the problem.
1 point if you can get that one. 1 point if you can find the second derivative. So after all that work, plus 1. I mean, now that you know what you're looking for, it's a little bit easier to find, but still hard. Okay, so now we need to use that to explain why this is not the graph. We'll check this out. If I have 0 for B, I should have what sort of slope, or what sort of concavity, I should say. Because, again, this is a normal function, so second derivative is concavity. So we're using concavity. If I plug in 0, I get 100 minus, and then times this. It should be concave down. Where is it? Right here. This is concave up. That's the reason. This graph is incorrect because this should have been concave down until 100. So we write in words, should be concave down until B equals 100. And then it'll be concave up, because once B is bigger than 100, like 200, 100 minus 200 is negative 200. Negative times a negative is a positive, therefore you're concave up after that 100 mark. If you said should be concave down up until B is equal to 100, you can give yourself plus 1 point. How do they say it in the solution guide? Oh yeah, well technically I can't plug in 0 because you can't weigh 0 pounds as a bird, or 0 grams as a bird. So between up until 100, we should be concave up. Exactly how we answered it. So you have 1 point there. Let's move on to the meat of our equation, or the meat of our question.
Never mind. I was thinking, shouldn't it be until B is greater than 100?
Yeah, I was thinking about that too when I wrote it. Until B is greater than 100, greater than or equal to 100, right? Yeah, because yes, at 100 you're still not the right concavity. Yes, I like when students are formal, not pedantic. We're stopping using that word now until it's
You
actually.
use it so much. It's
I'm
like
stopping
daily
now
thing.
unless it's actually useful. But that was being precise. That is math practice 4, right? Being precise. All right.
Well, the thing is, he would never use it last year, and I kept forgetting what the word set it on the wall, and I would like look for it on the wall. I don't know, and now it's constant.
Okay, so the letters here are going to be a little bit confusing for us. It's capital B and lowercase t, but we'll solve it just like we did before. So I'm going to change this right-hand side. I'm going to make this 100 minus b all over 5 instead of 1/5 out front. It's the same thing, though. Are we all okay with that? Okay, so this is equal to 100 minus b in the numerator and 5 in the denominator. All right, I have a fraction equal to a fraction. Now I'm going to cross multiply. Cross multiply. I get 5d capital B. On the right-hand side, I'm going to do that in green. I get, in parentheses, 100 minus capital B times d lowercase t. Okay, I haven't separated because I have this capital B's mixing with the lowercase t's. I need this 100 minus b on the left-hand side. I'm going to divide both sides by the quantity of 100 minus b. Whenever you have parentheses there, you always divide by that entire thing, 100 minus capital B. So our new thing is going to be, oh, I see people that are way ahead of me. This is now going to be 5 over 100 minus capital B, d capital B is equal to nothing, d lowercase t. We have now done separation. You now get 1 point. Plus 1. Plus 1 in a circle. You can see in the solution or the scoring guide, separation of variables is always 1 point. All right, next step, shout it out.
Yes.
Integrate. Integral of 5, and I'm not liking these fractions, so it's going to be 5 times the quantity of 100 minus capital B to the power of -1. Good. It's kind of the same thing over and over. You're seeing the patterns now. Don't forget that d capital B to be formal about it. And I'm going to make this the integral of 1 dt, and I'm just doing that so you can see that there's clearly something there that I'm going to take the antiderivative of. Okay, ran out of room. I'm going to come back up here. All right, so normally when I take the antiderivative, I take this number, I add 1, and then I divide down. -1 plus 1 is 0. I divide by 0. Oh, must need a special rule. What's our special rule? Natural log. So it's going to be, I still have that coefficient up front, 5 natural log, and I need to have what sort of sign here? Absolute value of, oh yeah. So you can do taxman in your head and just make that a negative, or I can do it the long way.
So how do you do that part of it?
So let's come back here. I need to use taxman. Why?
Because
Always look at your dinner.
oh,
Dinner is the derivative of the inner. Here's your inner. Take the derivative, Gio.
negative.
Negative, yeah, it's with respect to capital B now, so it is in fact -1. If it's not 1, which it is not 1, it's -1, then you need taxman. So taxman, I need a u. I need a taxman. I need a u prime. The u we already identified is 100 minus capital B. Our taxman is 5, and our u prime is -1, as Gio said, which means I'm going to pay taxman -5. So I'm going to rewrite the integral. This is now the integral of -5. Sorry, I've paid the taxman his -5, which is kind of funny because that means the taxman owes you, theoretically, in that metaphor. 100 minus capital B all to the power of -1 d capital B, and that's still equal to the integral of 1 dt. Now that I've applied taxman correctly, I can take the antiderivative using that natural log, so -5 natural log of absolute value, 100 minus capital B and absolute value is equal to, okay, how do I take the antiderivative of 1?
You add 1 power and then divide that.
Yeah, so this was 1x to the 0. That's the same thing as 1. Now it's 1x to the
Second.
1. Or it's a t, yeah, sorry. Go back here and make that a t. 1t to the 0. And now it's 1t to the power of 1. Divide down by 1. There it is. So it's just t. Come back here and just say that was just t. And don't forget your cake. And I try to make my T curly, my plus sign not, so they look a little bit more distinct. All right, so let's talk about how many points we got. We got only 1 point for the antiderivatives in this case. Only 1 point for the antiderivatives. So I only get +1. I'll put it right underneath the equal sign. If you ever see me giving you a +1 right in the middle, that means it was 1 point for both derivatives. Obviously, the antiderivative 1 is so easy, that's their logic. And then 1 point for your cake, 1 point for your constant of integration. Yep, right over there. All right. Step 1 was separate. Step 2 was integrate. Step 3 is to evaluate. Yes, to plug in. So I'm now going to rewrite this green equation, but I'm plugging in our lowercase t is 0 and our capital B is 20. So -5 natural log. Absolute value still I haven't taken it yet. 100 minus capital B was 20. And absolute value is equal to 0 plus c. And then I Normally on the AP test, you'd stop here, but I'm going to push you guys one step further. Just simplify a little bit. This is -5 natural log of 80, and I can just drop the absolute value because absolute value of 80 is just 80, is equal to C. Now I will give you your 1 point for your evaluation. And again, we have step 4, which is to isolate, which isn't that hard again. There's not too much of an issue happening, but there it is. I'll do that. I don't have much room for it. Maybe I'll just add a piece of paper on the digital file and upload that later. Let's do number 3. How are we doing on time too? We get out of here at 12:45, is that right? That's not what I meant to share. We got this. Yeah, you guys only need an hour, so I have 45 minutes. I would like to give you more time just to make sure that we aren't stressed. Okay, we need to find the second derivative. Here's the first derivative, and I need to figure out if it's concave up, down, or neither. So this is going to be using product rule no matter what. Even if we distribute this, this is still going to be 3y to the power of 3 minus 2xy to the power of 3. I'll still be using product rule right here, or I could just be using product rule here. So I think it's better to just use it without having to do extra math. So I'm not going to do that. I'm going to come back down here, and product rule, shout it out, is 1.
D2 plus 2d1.
There it is. So 1, that's y to the power of 3. D2, well, that's the derivative of 3 minus 2x, which is, there it is, -2. Plus, what is 2?
3 minus 2x.
Perfect. And then D1, that's the hard bit.
3y to the third. To the power.
Second power times dinner.
3.
Y prime. Whenever you take the derivative that has a y, you will always have a y prime that pops out. On the 8, if you were an AP grader and you stop right here, you get your point because you've now officially taken the derivative correctly. But in my class, I need you to simplify. So here we go. We're going to simplify this to, let's change the yellow here. This is negative y to the power of 3. Wait, what happened there? Thank you. Negative 2 y to the power of 3. And that's going to be plus. And these things are going to have to all be multiplied. So I'm going to have a 9y squared y prime. That's these two being multiplied by the 3.
Great.
Then I'm going to do these two multiplied by the -2 to get negative 6xy squared y prime.
This isn't complicated at all.
I know, it's hard. This is AP level. And then from here, I'm going to factor out the greatest common factor. There's no coefficients that I can factor out. There's a y in each of these terms, but no y primes. The biggest y that I can factor out is what? Y squared. Y squared, and when I factor that out, I'm left with negative 2y plus 9y prime minus 6xy prime. Let's just know, why'd you factor that out? I don't know. I am just so used to factoring out. You guys need to be like super proficient at factoring out things if you're ever going to do this type of problem to try to get the point. But on specific solutions, as long as you know how to do part C, then you're going to get your points. All right, so we found d squared y over dx squared. We found the second derivative, so we can now give ourselves +1. Find, I don't have the solution guide for this one. Oops. Is this based off of a problem? I don't know. Okay, I'm just going to make stuff up. I've seen lots of these. You probably get +1 point for that. And then you need to figure out if it's concave up, down, or neither. So I'm going to plug in 2.5. And you have to plug in this number to both the first derivative and this second derivative that you found. Why? Well, because in order to find what your y prime is living right there. I have to find what that is too. So really quickly here. Our y prime, when we plug it in, is equal to, well, a half is our y, right? So our y is a half, our x is 2. Our y prime is 1/2 to the power of 3 times the quantity of 3 minus 2 times 2.
Okay.
So 1/2 to the power of 3 is 1/8. Because this 3 gets kind of distributed to the top and the bottom. 1 to the power of 3 is just 1. 2 to the power of 3 is 8. That's where that came from. Next, 2 times 2 is 4. 3 minus 4 is -1. So the answer here is -1/8. That's just y prime, which is going to be useful for B because it's going to ask what is the tangent line. We'll need that slope. But we also need to plug that in for each of these y primes. It might be easier to plug into this equation, I'm feeling. It is, yeah, there's a few points that happen here. It's going to be, I'm going to say this is equal to -2. Our y-coordinate is 1/2, plugging that in, to the power of 3, plus 9 times our y-coordinate, again, is 1/2. All that to the power of 2. Our y prime that we found up here is times -1/8. -1/8. The cool thing about this problem, I'll pause right now, is you don't have to find out what number it is. You have to figure out if it's positive or negative. That's it. Because it's only asking concave up or concave down or neither. So from here, I need to plug in, so minus 6x, x is 2. So 6 times 2 times y squared, so times 1/2 quantity squared, times y prime, so times -1/8. So I'm going to go through this and look if it's positive or negative. Oh, shoot, we might have to calculate roughly what it is because we're adding and subtracting instead of just purely multiplying. That is rough. All right, sorry, guys, here we go. 1/2 to the power of 3 is an 1/8. So 2 divided by 8 is 1/4, so this is -1/4 right here.
Yes.
1/2 squared is 1/4, so this is -9/32.
Yeah.
Whew, lots of multiplication coming up here, guys. Here we go. 1/2 squared is 1/4. 2 times 1/4 is 1/2. So right here, this is 1/2. 1/2 times -1/8 is -1/16. Is positive 6/16 or positive 3/8. I'm going to leave it as 6/16 because I think we're going to have common denominators. So I'm going to multiply this by 4/4, multiply this by 2/2, and I get the numerators that I only care about. I have a -4, I have a -9, and I have a positive 16. So 16, a -9, and a -4. I need to know if that's positive or negative.
Why is it positive 16? Is it
It's
12?
positive.
Positive 18. My bad.
So it's
Wait,
concave
Wait, you
up.
didn't-
12.
You didn't-
12.
times 4 is 16.
Okay.
Yeah.
Oh my gosh, Mr. Sindel, why are you doing this to us?
It's gonna be
It's
negative.
not-
Can we just say we know
Wait,
it's
no.
gonna be
Multiply
negative?
that by 8.
Because
No, negative
automatically,
Yeah, you're right.
automatically we know that -1/4 is bigger than 6/16, so it's gonna
Oh yeah, that's a good way of doing it too.
Yes.
automatically, so that
Good
there's
way of
negative.
So these, yeah, that's a good way of thinking about it. These two are negative, and a negative plus a negative is a negative. So we know from here, yeah, do whatever tricks you can. This is going to be a negative answer. Therefore, we conclude, if is it concave, Yeah. concave down.
So do you not get the point if you say concave down if you don't get any of the math right?
So I'm pretty sure you get 1 point if you find out that it's negative. So let me come down here. 1 point if you find out it's negative, and 1 point for drawing a conclusion. That would be my guess.
So if
Because
you
you gave
guess
us 2
concave
points,
down.
and I said it was concave down, but you gave me 0 points because
I-
I did the math horribly wrong.
Oh yeah, you don't get your point if you can't do the math.
Oh,
That's fair.
Because that's essentially just guessing. It's a
That's
50-50 shot, right?
It's actually a 33.333 because it also says neither.
Okay,
So-
that's a fair point. All right, equation of the line tangent. Y minus blank is equal to blank times x minus blank. All right, so this is our y coordinate, our x coordinate, and this is going to be the slope. I highly recommend, if you saw this problem on the test, skip A. You could do B without doing part A.
Woo. Oh, we love that.
Because, yeah, you're plugging in the x coordinate of 2, the y coordinate of 1/2. So x coordinate is 2, y coordinate is 1/2. The only thing that we're missing to get all of part B is the slope. And hey, it gave you the equation for slope right there. Right there.
Mm.
And the slope is -1/8.
Computer's
Did you
fried.
just delete?
No, sometimes it just like messes up. Yeah, so let's come down here and we're going to say, yeah, we already calculated it. We don't need to do anything. There it is, -1/8. We're done. And that's kind of cool about these problems is AP graders will look at all of question 3. They don't be like, I look at A and then pass it off to the next person to do part B. They'll do the entire question, which means if you wrote your answer for this -1/8 in part A, they will see it and they'll be like, oh yeah, they show their work. They're good. Yeah, so I'm going to guess... I'm going to guess only 1 point for this entire equation because you should have found this -1/8 already.
That's what you gave us.
I might come back and revise that statement later, but let's go on to part C because it should add up to 9, right? It should add up to 9 for every AP test. This one I said that it was out of 8 because I'm giving you extra credit, a chance for extra credit. You can get like 6 out of 5 if you do that last step that I didn't expect you to do. And that's going to be the same thing for all the other problems where I'm like, I'm not going to teach this, therefore I'm going to make it extra credit. Learn it on your own. So I'm going to treat this as a fraction. dy dx is equal to y to the power of 3 times the quantity of 3 minus 2x. All of that over 1 exactly. Then cross multiply. So cross multiply, I get 1 dy in yellow. In green, I'm going to cross multiply the other way, and I get all of this stuff squished together. Y to the power of 3 times the quantity of 3 minus 2x, and the quantity times dx. Okay, right now our x's and x's are matching up, but the y's are being mixed over, so I have to divide both sides by y to the power of 3, and I get, let's do this in black. There it is. Thank you, Jim. Cool. That was step 1. Separate. You get 1 point for that. You always get 1 point for separate. Next, we're going to do what?
You want to integrate.
Integrate. This is now y to the power of?
Negative
3. Over here I have the integral. I'll just leave that all. 3 minus 2x, that quantity times dx. When I do my integration, y to the power of 3, I add 1 and divide down, so it's going to be y to the power of?
Negative 2 over negative 2.
There it is equal to? 3x, because antiderivative of 3 is 3x. Antiderivative of negative 2x is?
2x to the second.
Divide by 2, exactly. Add a power, it was a 1, it adds to 2, and then divide down. No. Yeah, after I take the integral, I get rid of the integral and the dx. And don't forget your cake. It's a full point, always, always. All right, so I have to choose the level of difficulty. I think that those were kind of easy. I'm just going to give 1 point for both of them and 1 point for the constant of integration.
You gave
I give a point for each of them? Oh, okay. I stand corrected. Those were hard enough to get a point apiece. +1, +1. And +1 for the c as well. I'm going to go ahead and rewrite this equation without negative powers. It's really 1 over negative 2y squared. That's how I rewrite this. I'm going to rewrite everything else from there without changing anything. So it's equal to 3x squared minus x squared plus c.
Isn't it 3x?
Yes, thank you. Do we still have extra credit trackers in here?
I don't have one.
Here.
Try to remember.
Write it down on a piece of paper.
Plus c. All right. And finally, we do step number 3. What is step number 3?
What's the
17th today.
18th?
Today's the 18th, right? Sorry.
Oops.
Our x coordinate is 2, our y coordinate is 1/2, so I'm going to plug those into my green equation. You should plug it into that one because plugging into something that has a negative exponent is kind of difficult unless you're, I mean, if you see steps ahead, that's fine. I just know that you make less errors when you get rid of the negative exponents and then plug in. So I have 1 over negative 2 and then y squared, so it's 1/2 quantity squared. That's still a fraction. That was on the left-hand side. On the right-hand side, I have 3 times 2 and then minus 2 squared plus c. On the AP test, you would stop there. On my test, you continue. 1/2 squared on the left-hand side is 1/4. Negative 2 times 1/4 is negative 1/2. So I have, and I'll simplify this in a sec. 1 divided by negative 1/2. On the right-hand side, I have 6 minus 4 plus c. Okay, one more simplification that you have to do for me. I really, if you know how to do this, you can be like, oh yeah, that's negative 2. If you don't know what you're doing, think of this as 1 divided by negative 1/2. And then I'm going to keep it, change it, flip it. 1 times negative 2 over 1 is just negative 2. That's where that negative 2 came from. Is equal to 2 plus c. Just right there, you get your +1. You just do a little bit more math to figure out what your c is equal to. C is equal to negative 4. But you don't need to do that. You don't need to do any more steps. You got 1, 2, 3, 4, 5 points just for doing those first 3 steps. Step 4 is to isolate. I'm not going to do that on video. Questions on any part, or question 1, 2, or 3? We're moving on to the multiple choice. Whenever I have x goes to 4 for the limit, that's always a double-sided limit. I'm checking that the left side, or the left height and the right height are equal to the same. I don't care what height happens at this point. Basically ignore it. You can cross it off. At 4, I don't care. I'm just checking that the left and the right have the same height. Well, they both get to the same height. I can ignore that point. So yes, you can circle that one. The left height and the right height, yes, they approach the same point. The limit does exist. So I can circle 2. The left height and the right height, oh, now they're not going to the same height, so not for 3. The answer is 1 and 2.
Those going to the same height?
This has a height of 1, 2, 3, 4. This has a height of 4, and this has a height of 1, 2. These numbers need to be the same height.
Then y is 1 the same height.
What is the same height? Again, you ignore this point. You only look at the limit as I approach that point. The limit as I approach this point has a height of 3 on the right. On the left-hand side, I get to a height of 3. So you ignore the point that's right here. I only look at what it approaches. Just ignore the thing that happens at x is equal to 4.
All right.
Number 5, product rule. I have y is equal to this, and there's 2 variables. I have an x and an x, so product rule, 1 d2 plus 2 d1. 1 is x squared, d2. Doubter for e-house is e-house. Then dinner is x, or sorry, inner is x. The dinner is 1. I don't have to worry about dinner. Plus 2. 2 is e to the power of x. d1 is 2x.
2 dinner.
And then I factor out both of these terms have an x. There's an x there and an x there. Both these terms have an e to the power of x, so I'm going to factor out x e to the x. If I factor out an x e to the power of x, I'm left with x plus 2. And there it is, C.
Oh, because you're inflecting 1 and 2.
On to number 6. All right. I need to know the definition of inflection point. Go. FIP.
Where f double prime sign change.
Good. F double prime sign change. You have to have those memorized.
It's like a negative power? Like an odd power?
Yes. You can only have a sign change when it's in factored form and I have odd powers. It's in factored form, so let's look for odd powers. Odd power, odd power. Don't worry about that guy. It's an even power right here. Even power of 2. So I have 2 inflection points, and they happen when I set that equal to 0 and set that equal to 0. Set x equal to 0. Oh, done. Set x plus 1 is equal to 0. Oh, that gives you x is equal to negative 1. So the answers are 0 and negative 1. C.
Ah, okay.
Number 7. Slope of the line tangent. You might be thinking, oh, line tangent, that means y minus blocks is equal to blah, blah, blah. No, it's only looking for the slope of that, so I'm only looking for the derivative. So take the derivative, and it's going to be a little bit hard because you have some y's in there. So here we go. The derivative of 3y squared. Well, the 2 comes down in front, so it turns into 6y. And don't forget your dinner, y prime. Whenever you're taking the derivative with y's, you will always have a y prime that pops out for your dinner. Or maybe it's your dinner inner. You'll somehow have a y prime. Okay, minus. Take the derivative of negative 2x squared, and it's negative 4x. Take the derivative of 6. Constant term, so 0. And now this is the tricky bit. It's product rule. I have 2 variables that are being multiplied together. So I'm going to have to do 1 d2 plus 2 d1. So I'm going to consider all of negative 2x to be 1. And I'm going to consider y to be 2. All right, so 1 is negative 2x. d2 is y prime. Plus 2 is y. d1 is negative 2. As soon as I can, since I can plug in ASAP, I'm going to plug in now. So the x is 3, the y is 2. So this is 6 times 2 y prime minus 4 times 3.
Question?
Yes.
Isn't that supposed to be negative 2x y prime?
Negative 2x y prime.
Uh-huh.
So d2, the derivative of y, what is d
Oh, never
dx
mind.
of y? It's just dy dx, which is equal to y prime. Yeah, good question. And then just minus 2y, or minus 2 times y, and y is 2. Maybe I should make that plus 2 times negative 2, and it'll make it stand out better. From here, I just need to simplify. This is going to be 12y prime minus 12 is equal to negative 6y prime minus 4. I'm going to get my y primes on the left-hand side, so I have 18y prime. I'm going to get my constants on the right-hand side, so I add 12 to both sides, I get 8. divide both sides, and I get y prime is equal to 8 over 18, or divide 4 and 9. 4/9, correct answer, B. And our final question on the pretest. I think so, right? Yeah, number 8. It's just going to be doubter times dinner. So the most out house is the trig house, cosine. So the derivative of cosine, I'm going forwards. I'm going to negative sign, exactly. So this negative sign, and then I leave the inner. I do not touch it yet. It's still 2x. Then I multiply this doubter by the dinner. The derivative of 2x is 2. I'm looking for something that says negative 2 sign. Oh, wait. What am I doing? Oh my gosh, Mr. Sindel. Yes, we took the derivative correctly, but we're not taking the derivative. It said the derivative is already that. We need to find y. We need to go backwards. We need to take the integral of cosine of 2x. My bad, dx. So anti-change. Wait, hold on. We always, every single time, we're always going to find dinner. Going forwards, going backwards, we're always finding dinner. What is dinner?
Sine.
No. What is dinner?
2.
Yes. Is dinner 1?
No.
Therefore,
X.
taxman. We'll need taxman. We already figured out that the u is 2x. The taxman, there's no taxman, so I'm just going to make him 1. And u prime is equal to 2. I'm going to pay taxman 1/2. That's why all of these have a half in them. So when I now have the integral of 1/2 cosine of 2x dx, I paid taxman a half. There it is. Now I can take antiderivative. Anti-C for change. Anti-change means same. It's going to be the same sign. It was positive. It will be positive again. 1/2 sine of 2x plus c. C is the correct answer. Questions?
Oh, God.
All right, we're going to take a 5-minute break, and then we're going to do the test.